Hey everyone, I am Miss Hu, your physics teacher. In this video, I will be discussing the answers to a past year question and then we will compare the answers to the mark scheme. For some questions, the answers will be covered first so that I can explain the thought process of getting to the answers, as you will need to know how to get the answers and not just what the answers are. Then, based on the mark scheme, I'll explain why the marks are awarded as such. Question 1a. Circle the vector quantities in the list. This is a recall question. You need to know what vector quantities are. Vector quantities are quantities with magnitude and direction. So because this is a recall question, it means that you need to remember which are scalar and which are vector quantities. And yes, you do need to read up about this. So because this is a recall question, you have to know it or you don't. The answers are, of course, acceleration and velocity, as shown in the mark scheme. So because the question asks you to circle, you circle the answers. So you can see based on a marking scheme, you need to get both in order to score 1 mark. Now let's go on to 1b. Figure 1.1 shows the speed time graph for a train traveling from station A to station B. So on the y-axis we have the speed, and on the x-axis is time. 1. State the maximum speed of the train. Because this is a speed time graph, all you need to do is look at the graph and identify where the highest value of speed is. And it's of course along this section of the graph. So if you look at the graph, you'll find that the value can be determined from here. And you should be able to see that the answer is of course 56 meters per second. So we are of course referring to the section of the mark scheme for those who are able-bodied. I'm not referring to the Braille answers because we are not doing the Braille version of the paper. So based on the marking scheme, identifying the correct maximum speed will give us 1 mark. Now let's go on to number 2. Describe the motion of the train between station A and station B. So as the question already stated, the graph is showing us how the train is traveling from station A to station B. That means at 0 seconds, that's station A, and at the end of the journey on this point of the graph, that's station B. Now if you look at this graph, you can see that it's been divided into 3 sections. So you need to describe all 3 sections of the graph. And to make it very clear, you must state from what time to what time and how the motion of the train is. Now ideally, when you describe the motion, you should state from what time to what time and how the motion is. So normally, when we want to describe the motion, there are 2 terms you must use. You must mention whether it's speed or acceleration and its descriptor, meaning whether it's constant, increasing, decreasing, or 0. So from t equals 0 seconds to t equals 80 seconds, you can see that it's a straight line from 0 speed up to 56 meters per second. So this straight line means that it's increasing speed at a constant rate. So I'm going to write here from t equals 0 to t equals 80 seconds. The train is moving with constant acceleration, or you can say increasing speed. So next I'm going to write from t equals 80 seconds to t equals 480 seconds. The train moves with constant speed. And finally, after that, all the way to 530 seconds, the train is decreasing speed at a constant rate, which means it's undergoing constant deceleration. So from t equals to 480 seconds to t equals to 530 seconds, the train is moving with constant deceleration, or you can say with decreasing speed. So notice how in each of these statements, I mentioned the time, as well as whether it's acceleration or speed, and its descriptor, constant, increasing, decreasing, or 0. Now, when you look at the answer though, they don't mention the time. It so happens that for this particular mark scheme, they're quite lenient in a sense that you just need to mention whether the train is accelerating or increasing speed, constant speed, and then decelerating or decreasing speed. And an additional mark is given for mentioning constant acceleration or constant deceleration. So why am I writing so much over here? Because there have been some past year questions where marks are only given when you mention the time. So my suggestion is to be safe, write out all the information you can see from the graph because you don't know whether for that year they're being lenient or whether they're being very strict. So in my case, I've written a lot of information here, but it is based on the graph. And even though there's a little bit of extra information here, we're going to get our 2 marks because we have mentioned everything as per the mark scheme. So yes, a little bit of extra information here, but better to be safe than sorry, in my opinion. Now let's move on to number 3. Calculate the distance between station A and station B. So in order to calculate the distance from a speed-time graph, let's recall, you need to calculate the area under the graph. Now, in case you don't remember how to do this, I've explained this in my video on motion graphs, and I've put the link to that video in the description below. So because you need to calculate the distance between station A and station B, we need to calculate the area of this entire graph. Remember, this graph is showing us the motion of the train from station A until station B. So the shape of this graph is a parallelogram. So you can calculate this area by using the equation for a parallelogram, or if you can't remember it, you can divide this into a triangle, rectangle, and triangle, and just total up the area of all 3 shapes. So to get the mark, as long as you show that the distance can be calculated based on the area under this speed time graph, you can get 1 mark. Whether you use the area for a parallelogram or triangle plus rectangle plus triangle, you're still going to get 1 mark for the working. So because I have already worked out the time, I'm just going to use a triangle, rectangle, triangle method because I'm a little bit lazy that way. The first time segment is from 0 to 80. So I'm going to write 80, and the speed, of course, is 56, as we've already determined from A1. For the second segment, where it's constant speed, the time is between 80 to 480. So we're going to write here 480 minus 80. Because it's a rectangle, we just need to multiply the length and width. So that means, in this case, times 56. For the third segment, it's between 480 to 530. So because it's a triangle, that's why I have my half over there. So 530 minus 480, and of course, the speed is 56. So working this out, you will get 26,040. If you're not sure of the unit, remember, check. This is meters per second, so you will get meters. Now, when you write the answer out though, we're not going to write all the numbers out because remember that for Cambridge, they accept answers between 2 to 3 significant figures. The preferred is 2 significant figures. So I'm going to write here 26,000 meters. Alternatively, if you want to write 26 kilometers, that's fine as well. You just need to write one, don't write both. So for the mark allocation here, as long as we get the correct number with unit, you will straight away get 3 marks. But just to break it down, in case you didn't get these full marks, you can get mark for mentioning the distance under the graph. So that's 1 mark. And you also get 1 more mark for the correct substitution, which is over here. So anyway, because we got the correct answer with the unit, we're definitely going to get 3 marks. So that's how the mark allocation works. Now, just to backtrack a little, what if you identified the wrong value of the maximum speed? If you identified the wrong value, obviously you're not going to get marks for A1. But if you use the values correctly in your calculation here, you can still get full marks. That's why it's important to show your working. If you don't show your working and you only write the final answer, if you had identified the wrong value of the maximum speed and you show absolutely no working, you would get 0 because they don't know how you got that value. So by showing the working, if let's say you had the wrong number, instead of 56, you wrote another number out, you can still get full marks because of the concept of error carried forward. But that only works if you show your working with the correct substitution. Now let's go on to number 4. For number 4, the question is, on a different day, the train takes 650 seconds to travel between station A and station B. Suggest one change to the motion of the train that leads to this longer journey time. To answer this question, this is not related to the graph, so you cannot find the answer in the question or in the graph. So this is not asking you for the reason why the train takes a longer journey time. The question is very specific in this case. They're asking you to suggest one change to the motion. So how do we answer this question? So motion always refers to talking about the speed or acceleration. So you only need to suggest one change to either the speed or acceleration. To get a longer journey time, obviously the train needs to be traveling more slowly. So you may suggest that the train is moving with lower speed. But remember that when a train is moving, it could be changing speed throughout. So what kind of speed are we referring to? It is possible that it has a lower maximum speed. Could that cause a longer time? Yes. Or maybe a lower average speed over the entire journey. Also possible. Or maybe at the section where it's moving with constant speed, it could be a lower value as well. So all of these are reasons why the journey could take longer. So do be more specific. Don't just say lower speed, because which speed are you referring to? So you could mention it's a lower maximum speed, or you could say lower average speed, or you could say lower constant speed. So these are some options which you can use. Similarly, a lower acceleration could also lead to a longer journey time. Another way to express it is by saying less acceleration. So lower acceleration here means that change in speed over time is a smaller value, so it takes a longer time to reach the maximum speed of the train. A lower deceleration can also cause longer journey time because it takes a longer time for the train to lower its speed or to come to a stop. So longer time to decrease its speed. So that's why lower deceleration is also accepted. You can also express this as less deceleration. Now, you don't have to write all three. Just write one of it would be enough for you to be able to get 1 mark. And that's how you answer this question. If you found this video to be helpful, click like and subscribe. And do let me know how you have found this video to have helped you. To watch videos on other questions, check out the playlist on my YouTube channel or on my website, physicsrocks.com, to find the question that you are looking for. If you have any requests for a particular question, drop your request in the comments below, stating the year, month, variant, and question number. And if I haven't covered that question yet, I will do my best to come up with the explanation video as soon as possible. All the best for your examinations!